Hi, I'm Ikea, and for today's video, I want to have an in-depth look into medium maths, which is a continuation of the simple calcs video, basically, which I'll link in the description, as I'll expect that you'll know the concepts, at least, of those. They are the simple calculations, of course, so I'm assuming most will know them. And in this video, we'll go over several things, and some of you may have noticed actually that this video went up a few days ago, and then it went down again as I took it down, as I had become convinced by the arguments of some of others, of my peers basically, that crit chance, crit damage should be done otherwise than it is stated in that simple calculations video. And I had been convinced by their arguments. They were quite convincing in that. But then actually in checking it, I disagree. It should be done the way I laid out in the simple calcs video. And that's also what we'll be then proving first here, turning this a little bit into a for no particular reason video, but we'll go over, and show why that calculation should be done that way, where it's just crit chance times crit damage, bigger number wins, and you can basically, it doesn't matter in what format you're doing that in for that. And then we'll also go over some of the quirks of additive systems, where at certain intervals we can say how much we gain. So for instance, at 100 weapon damage, if we add in 10 weapon damage at that point, at the final result, we're only gaining 5% extra output. And there is a predictable model there, so we can actually explain that. And knowing that can be really handy just to quickly do the maths in your head of, okay, I'm adding in this much of this stat, we're going to get at this much of final output. Then also we'll go over some of the shortcuts that we can take, because we don't actually need to always do the full calculation. You can just actually take a bunch of shortcuts if you aren't interested in, for instance, playing around with the stats, but you just want to know, the calculation together. Then also we'll go over actually some, even taking a bigger shortcut and taking it to a build multiplier, where we can just compare the combined multiplier of a build against other builds, basically. That's actually a handy trick to know. So let's go get started. And let's actually start by discussing crit chance times crit damage and how to balance it out. In the simple calcs video, I laid out that, we should do it just crit chance times crit damage. The format of each doesn't per se matter, as long as we kind of do it wrong for both of them. So we just could take 57 times 142, even though technically these are, of course, all, this would be a 0.57, this would be a 1.42. Both of them would be divided by 100, because both of them are percentages. So in calculating them out as a multiplier, we would need to divide them by 100. And we can't skip that, just going by the full numbers, as long as we do it wrong for both sides. So we would just do 57 times 142 versus 60 times 130, and bigger number wins. Now, there is a whole other side that goes that what we should do is, and this was the argument that I was kind of actually was convinced by enough to include it in the previous version of this video, basically, that no longer is up, because I am now very much convinced that that isn't the case. And that is that you should treat the crit damage side of things different than the crit chance side, because this is a multiplier, this is a rate. So that was actually the reason as well that I was like, oh yeah, actually that kind of makes sense, except that it doesn't work out, because at the end of the day, we should just have a system that matches up to, for instance, what we get out of a multi-calculator like this, doing the full DPS calculation. Because what we're trying to avoid there, of course, is doing the full DPS calculation. First off, actually, let's introduce the build, what this is based on, and that is just a striker, as we have it here, without a coyote, specifically. And I've specifically taken this one just because it will actually, with the different methodologies, will lean one way or the other. So we're here on 57 crit chance. So we're foregoing the coyote. We're not expecting a coyote from anywhere else. We're just running this solo without coyote, which I wouldn't recommend. I just prefer the coyote there. It basically does more damage in both ranges. So this 57 142 that we have here, that one is the numbers that we're taking here. And then of course the option would be to go to cap at 60, and that will mean that we're just adding a 6 crit chance mod here, wasting 3 of it basically, and then flipping this crit damage to have minus 12 basically, as we're flipping a crit damage to a crit chance somewhere on the build. And that's the numbers that we're then comparing here, although not per se that important, but just to also show that this is kind of a real world example. Then we're taking basically all the other numbers, and here we can see actually with the full DPS calculation that the 57 crit chance version that we have at the top is actually beating out the 60 crit chance version with a 130. Now this is then excluding, because there could be more discussion here if we're running killer or something that would benefit from this 57 and such. That's outside of the scope here. But we're going to keep it just to the crit chance, crit damage, and how to balance it out, at least just for a DPS sense of things. So when we have these, yeah, we can say that the 57 version is better than the 60. Now then, yeah, the other side is saying we should treat this as a multiplier. And this is actually, so in this calculation, and one of the reasons I realized that actually, no, we shouldn't, is that in this average damage, in this average shot here, I'm actually not treating it like that. And this is, of course, what we're basing the calculation on. We're turning all of these numbers down into an average shot. That average shot is going in here, and then with the RPM divided by 60, we're getting a burst DPS, and then with the mag size and reload going into there as well as sustained DPS. So this average shot then is the crux of it. Here with it, we are doing actually 1+, and then crit chance, crit damage combined in parentheses. So they are first multiplying against each other and then gaining a 1+. The crit damage isn't treated as a separate multiplier to reach these numbers. Then my question was like, wait, am I doing average shot wrong? Which would be weird. And also, I shouldn't have even doubted that, because my calculators line up with basically everybody else's calculators. So unless we're all doing it wrong, yeah, unlikely. But then also we can test that, because there's other ways of calculating that average shot, which we, for instance, laid out in there. And I quickly just did that just to be sure. Just, you know, let's cross all the T's and dot all the I's. So one of the ways of, as we laid in the simple calcs, to do average shot is we take the body shot and the body crit. For instance, if we're just looking at body shot numbers, that's also why the headshot here is just set to 0 the whole time here. We're not including headshots, but we would just need to take the other numbers for including headshot. Then, yeah, we have these two numbers, and then basically with the inverse of crit, so we have 57 crit, so this becomes 0.57 crit chance, or chance to crit when we're multiplying, of course. Here, the inverse of it, 0.43, basically 100 or 1 minus this as a multiplier, which is a 0.57. So we get a 0.43, that gets you this number. If you then do the crit side in the same way, but then without inversing this, of course, you get that number. Adding those two together, you get an average shot, basically. We're just taking the non-crit side and just percentually decreasing that to an average shot, and then the crit side as well, and then adding them together into an actual average shot. We see that these two numbers line up with these two numbers. So, well, at least with rounding, because yeah, this would round up, this would round up, and then we would reach these numbers. And that's exactly what is kind of happening here, except I'm doing it a little bit differently, and I'm just combining some of the steps. And especially in here, yeah, in there, the crit chance and crit damage is multiplying together first, before any 1+ comes into the equation. And then we can actually see, can we match these numbers? Because one of the reasons that I was like, oh, they might be onto something, is that if we take, for instance here, and I'm just gonna do the, you know, changing them into the multipliers just here instead of just dividing by hundreds in all of these cells, just to fill them in quickly. So these would be the numbers as we have them there, but then turned into multipliers. If we do these, is this number times this number, and then we do is this number times this number, and this is a percentage calculation there, where we dividing this number with that number up there, so that we get this 0.78 divided by this. It's a 96%. This doesn't line up with this. That was the reason that I was like, oh, okay, they might be onto something, because yeah, this never lines up. Not that I actually had checked too much, because I would always just do it in this method and then, you know, just take the results. But I was like, oh, okay, so that doesn't line up. Maybe they're onto something. But actually it turns out that it's due to something else. Because if we also then take what the numbers that as they kind of present them, so then what we do is 0.57, this same 0.6 for this, but then this 1.42 would become a 2.42, basically gaining a 1 plus as a representation of base. If we do that same thing and actually take this whole segment and place it here, what we see, actually I didn't do this one, 2.3, yeah. What we see then is that this number also percentually doesn't line up here. This was the thing that I actually did after that video, and I went like, oh, wait, neither lines up. Wait, so how do we line up? And the answer to that actually turns out to be is that the 1 plus happens after this. Because if we take these numbers, and actually I'm just going to take this segment and just copy it down here, and then we're going to just do is this number plus 1, is this number plus 1. Now we get the same percentual difference between these two as we do up here. So 98.38 and 98.38. Meaning that this is still the correct way actually to balance out crit. It's just that we're not doing this step to take it to a multiplier, because this would actually be the multiplier of the crit chance, crit damage together, which we could actually, for instance, put up against, weapon damage or other things and see the percentual difference that we would gain from, for instance, adding a crit chance or crit damage into there. And dealing with it this way is the only way that we can line up actually with, for instance, here, a full burst DPS calculation. But that means that without that 1 plus, well, this percentual difference is different. That doesn't matter, because in the end of the day, bigger number here wins. So this number is bigger than that one. So that is the 57,142, at least from a DPS standpoint, just from a pure DPS standpoint, and not, for instance, including that killer is going to activate more. If you're running any talent like obliterate, it's going to trigger a little bit more, that stuff like that. Leaving that out, but just from a DPS standpoint, that 57,142 is actually going to beat it out. And the thing here, and especially why I picked up these two numbers specifically, or this build, is that if we do it in the other way, that is actually wrong, because we gain now the bigger number is this 1.38 versus this 1.379. This 1.38 would actually seem to be ahead, because we're actually, because of the way this is getting done, you're gaining more from the crit chance, basically. The crit chance not getting that representation of base in there is actually overperforming. But yeah, this was the original thing, is that this number didn't line up with this. And I was like, oh, okay, so there must be something maybe to that when people are talking about using this as the multiplier. I just should have checked as well that this one also doesn't line up. And there is no real way that I can think of to address this in any way where this would line up with this. And then the only one that actually does is treating it like this, where we do this, and then actually the 1 plus comes in later, and then they perfectly match up. Meaning that, yeah, it is still crit chance times crit damage. And of course, what we can do, numbers-wise, it doesn't matter if this is a 0.57 or a 57, and it doesn't matter if this is a 0.3 or 130, although actually, well, this 60 needs to be a 60. Except that on this end, now, this would be plus 10,000 on it to match up down there. So if we do it just with bigger numbers, which we can do, and this is the easier way to do it, and the recommended way, we just take 57 times 142, we get just bigger numbers out, and we can still even make that match up percentually wise. It's just that at 1, because of the 60 basically, and we're shifting on these, we're shifting a total of 4 decimal points because of how we're calculating it. We have to shift that 4 decimal points as well, making it a 10,000. And when we add that into this, then it aligns again as well. So yeah, we can just do crit chance times crit damage, just use the full numbers as an easy way. You don't have to turn them into anything else. And yeah, adding in a 1+ into that crit damage, something that I've said on stream as well a few times, turns out to be completely wrong. As we'll move to this second part, and that is that at certain intervals, actually we can say how much we're going to gain from a stat, especially if you know that value of the stat already. So here, for instance, I'm going to put in 0, 25, 50, and then 55, or no, 75, and 100 as just a few simple values. We're actually going to take this, and in the spreadsheet as well, we can just do this, and it will actually populate other numbers as they go. Now here, there is, of course, this, if we're having these as stats, let's say this is weapon damage as our stat, when it goes to being from the stat in the game, we're gaining that 1+, of course, as well. So these would be divided by 100, 1+. What we can do, of course, here again, as we kind of showed in that same way, although we'll actually take it onto the full steps. So what we'll do is this number divided by 100, so 1100 there, and put that, of course, all the way here. So these are now these numbers as their modifier. So this is that divided by 100. Now, of course, the way that would go into that calculation is +1. So if we're taking this number, and then, so this would be whatever is in this field +1. And if we actually take that same calculation and apply it to everything, of course, goes up by +1. Because, of course, yeah, we're starting with a representation of base, and then we're adding in the multiplier on top of that, because otherwise, of course, if you have like 20% weapon damage, you would actually be, taking your weapon damage. If that representation isn't in there, it will go to 20% of that. So there's always 100% base there. And then the number that we have on our stat screen is always on top of the 100%, because otherwise it would, of course, decrease the stat as long as it's underneath 100%. Because of this, there's also a very interesting quirk. And that is that we can very easily predict our diminishing returns that we would get for adding in a stat, especially at the 100, 200, and 300% point, for instance, here. And that is that if we take a 0.1, so a 10% increase for here we're just going to copy and paste that all the way down. Then formula-wise, we're going to add into this multiplier a plus. So we're adding a 10% into that stat, included into it as its separate multiplier. So yeah, we're going to a 1.1 there. If we take the same formula again as well and just apply it all the way down, then if we take a percentage version of this, so is this number, is this number, actually, divided by this number. So how much did it actually increase? Now, on the 0 point, it is a 1.1. If we take the same formula and put it all the way down, we see actually the effects of diminishing return, and the one we quite often discuss. As we have here at 0, that 10% going in takes us multiplier up and actually gives us 10% in return. If we're doing the same at 50, so if we already have 50 in there and we're adding in 10%, that 10% isn't actually increasing our damage. While it's going into the stat and increasing the stat by 10%, our final output, which is the thing we care about, of course, within these additive systems, there's always built-in diminishing returns. As you add in more into a stat, the less valuable it will become as long as it's additive to itself. And at 50%, we already see 0.60 or 1.066. So we're getting 66% of that initial input. So we're gaining 6.6% damage increase. If this was, we're just have the ability to add 10% damage. And of course, as well, this is an actual thing. For instance, with weapon damage, this would be adding in 10%. Well, if we had, 50% and then we had 10 grading into it, this would be our increase from grading. Now, as we go up, there is a pattern that emerges. And this is actually the really handy part to know. This is how I usually quickly in my head can give you answers to like, hey, how much does Memento, when it's fully charged up, add to this build? Or how much does this add to this build when I add 10 or 15% of something to it? And that is that at 100%, well, at 50, actually, we're 0.66. At 100, we're 0.5. Or 0.05, so 5% or 50% increase, let's just say it in percentages. So we're gaining 50% of what we actually put in. So we're putting in 10, we're getting 5 out of it. At 200, we're getting 33%. So we're putting 10 in, we're getting 3.3 out of it, 3.3 repeating out of it. At 300, we're getting 25%. So we're putting 10 in, we're getting 2.5 out of it. And at 400, as we have here, we're getting back 20%. So we're putting 10 in, we're getting we're getting 2% extra damage out of it. And that is the simple way to kind of visualize as well diminishing returns, but especially knowing, for instance, at 100, which is of course between 100 and 200, a lot of stats live between these 50, 100, and 200. If we have, let's say, 100 on a build with a Memento, which isn't, for instance, that rare actually, if we add 30% from the weapon damage of the Memento into that 100 from the build, what do we actually get at? We can already say that that's going to be 15 weapon, or 50, well, it's 30 weapon damage, of course, but it's 15% actual increase to the build. Now, of course, in between steps, it becomes a little bit murkier, but what you can generally quite easily do, so for instance, if it's at like, let's say 130, it's going to be somewhere between these two, of course, and I'll just round it out to being, you know, a 4 point something or 40% of what we're getting back. And I can give a quick answer to like, okay, how much does grading add in for you and such. And this is actually a quirk just of additive systems and very handy to know, because once we know that, yeah, at 100, each point that we put in, and of course reaching 100 isn't too hard, especially for instance, with headshot builds or something, you're going already into the 300s sometimes with hotshots and such. So every point we put in at beyond the 300, if we add 10% into there, we're actually only gaining a 2.5% increase to our actual damage. And yeah, this by itself is a very handy thing to understand and then actually put into practice as well. And next up, let's discuss actually how to somewhat simplify actually the damage calculations and kind of visualize it and talk through it. Because I feel a lot of people don't understand that you can just have the constituent parts of it separately. And while, of course, I very much enjoy using my damage calculators and such, where we take it from a base damage and we calculate everything out, that's especially handy for us to be able to, for instance, play around with the numbers. By doing the full calculation, we can just go like, oh, what if I have 20 grading on it and do plus 20 weapon damage without actually having the items and actually, you know, using them in game. But of course, quite often you'd be more interested in seeing what it is in game. Now here I've messed up a little bit of a build and just put something very quickly together, especially here. We're trying to avoid having any chest or backpack talents. That's why it's just a big bad mishmash of things. But what it is at its core, all of the red cores are here. We're not going to look at the crit chance crit damages, but if we just look at this weapon damage that we have here, this total damage, which actually is here truncated, of course, but here in the stat screen, it isn't. It is 104, 126. We're going to take this to the spreadsheet here, and we're going to actually put that in 104, 126. Now, this is the weapon damage as we have it there. But then actually, if I, of course, shoot an enemy here set to invulnerable at the range, that's not the number we hit for. Because, of course, that number, this number shown here, is literally just whatever the base weapon damage is with just these multipliers in there. So we have assault rifle active, that is our specific weapon damage, and it is our all weapon damage bonus here. And we can, of course, check that as well. If we go to the burst and sustain tables, one of the things that the burst and sustain tables are actually there for is for me to have all of the bases of the weapons. So if we copy the FAMAS's base as we have it there, and then take that back to our spreadsheet over here, if we input that, and then we had 130 weapon damage. That would translate into a 2.3 multiplier, as of course it's divided by 100, 1 plus 1.3 plus 1, 2.3. That is our multiplier for our weapon damage. If we take is this number times this number, we get the same result out, although with rounding errors, as that one's going into 0.75 even. And that is generally the base damages of the weapons. We don't have perfect numbers for them. There's actually a decimal point here, and the best I can do is round it out into a 0.5 or a 0 basically. But the actual number is a little bit different, and it's close enough basically. But this shows that that is just all that weapon damage does. Because also, if we now take it to the game, I actually had swapped out the backpack, for instance, here to have vigilance. But if we a second ago we had here the unstoppable force. If we take that again, actually, this is the same number weapon damage here. And if we take it to that vigilance, which would be active, of course, on if we shot now. And of course, we don't per se care about these stats. It's just the weapon damage and balance that we're kind of looking at here. The number here stays the same. Only thing affecting this is really that. And there's a quirky thing that Fi still breaks this number, as it does actually add into this number if you're running together with an FI or in the raids, not out in the open world, or if you're the FI yourself. Or countdown, which is the same rule set. If we take it back to this unstoppable force, especially, if we now shoot the target, we had, of course, 104, 126. Do we expect to hit that? We get 138, 592. Because, of course, we're shooting an enemy on health, and then what we have, of course, is 21% health from, or health damage from our AR. So what we can already check against, of course, again, is if we take this number and we do 1.21, of course, the multiplier for that 21% is this number times this number, it is this number times this number, and we get a 125,992 as we have it there. That is, of course, still a little bit short of our 138 that we have there, and that, of course, comes down to there being detox, of course, as well. If we actually remove this one and then add in our detox, which of course is coming from our weapon, because here when we're shooting at the enemy, basically anything that would be active, that's also why I've taken unstoppable force, which wouldn't be active because we aren't killing anything, and we don't have, we have unbreakable, so that also isn't applying. Just to keep this simple, we of course can just very simply calculate these out. And of course, if you want the full calculation and such, I'll link again to the damage guide. But this just to show that we can sidestep parts of this, because we don't need to have the weapon damage calculation in there. We can just do this, for instance, only the things that are applying and taking the weapon damage from the game. Skipping this step, because that would be just this step. Of course, these all being separate multipliers, we can actually take out parts if we already have the solution for them, because we have, for instance, for that. Now, this is this times this times this, and I put one times too many. There we go. And now we hit this one. We hit this 138,592. If we take it back to the spreadsheet, 138,591. How much is it? 0.706. So it would be rounded up to that number, and that is exactly what is happening. So we can, for instance, just skip this whole weapon part here, just not have it. Just take the weapon damage from in the game and add this in. Now, of course, if we take this up and, for instance, and we can, and this is also the reason why we want to know the damage calculations, is we can predictively work with it. So if we now add in a vigilance, and it doesn't matter as long as it's a red core, we're not looking at crit and we're not headshotting or anything, so that part doesn't matter. If we take it back here, what we can do is, if we remove it from here, we can do 1.125, which is, of course, vigilance coming in there. So is this number times this number times this number times this number, and we'll predict we're going to hit 173, 240. I was already doing the rounding there. So it should be 173, 240. If we take it into the game, or at least close enough, and yeah, if we shoot a non-crit, game, hello, non-crit, there we go, 173, 240. Of course, the one time we want to have a non-crit, it takes forever. And yeah, that of course lines up there as well. So we can just go, for instance, yeah, from the in-game numbers, cut out a few steps. And even, of course, what we can do is, even if we want to know, for instance, now we have this 173, 240, 240. If we add in obliterate at full stacks, now obliterate here would be going into the same pool as this. So we can't take that actually. But if we take a glass, actually I'm going to likely take perfect glass in a second. So if we take perfect glass, as long as it's not within a different multiplier, because yeah, we have vigilance, which would be the same multiplier as obliterate, those would need to be additive. So we can't just multiply the way that we want to do here. But if I take a glass chest and I take just this number, which we're hitting for, times this 1.3, because that's the only thing that is going to change when I go from this chest, at least on the non-crit side of things, but of course this group as well. But yeah, we're taking a or the perfect glass for 1.3 multiplier, and we shoot again and get an non-crit, which of course doesn't want to for quite a bit. We get 225, 212. If we go back here, 225, 212. So we can actually just skip steps if we need to in between. And that is actually a handy trick to know, because yeah, if you're just, for instance, taking an obliterate, so for instance, a striker with obliterate to a striker with glass, for instance, one thing you could do is, let's say, for the sake of argument, you're hitting on the non-crit, you're hitting for exactly 200,000. If you're not running anything else that is total weapon damage, what you can do is this number divided by 1.2, which would be the multiplier, of course, of obliterate. That would give you this 166. So when obliterate isn't up, you get 166. When it is up, you're hitting 200k. And what we could then take is that same number as this 16666 is this number times 1.25. So for instance, if we're going from a Cheska chest with obliterate to glass, then we would hit this 208. And this, yeah, while a little bit dirty and will not always give perfect results, and you have to watch out, especially that if this was a build with vigilance, this number wouldn't line up. That would make this number not be correct either, of course. So as long as it's just a multiplier being replaced, for instance, with a different multiplier, going from an obliterate to a glass would gain us from that 200k. If we were hitting the non-crit for that, we're going to this 208. And that way we can actually, yeah, do quick and dirty maths without doing the full calculations, setting out the full build, filling it out a calculator. And these tricks, yeah, are quick and handy, and sometimes will save you a lot of time. And here, let's discuss one final thing, which is actually calculating builds, especially for the build side of things, as a multiplier. Because that's actually a pretty easy way to compare builds against each other. Now, generally, I also am interested in quite often comparing weapons against each other, or, you know, the same build but then different weapons. For that, we would want it to be DPS, especially. But for comparing builds against each other, a multiplier conversion is actually a pretty handy trick to know. So here we're taking an obliterate striker. Here I've taken just exactly this one, a Cheska Grupo, although actually not set up correctly, as this would need to be with a Coyote mask. Let's say we have a Coyote from somebody else. I've also taken out any damage talent here just for ease. We're just doing a non-damage talent here being preservation. And for the rest of it is just the build. And we're just concerned here with the crit number. So we've taken, actually, we're going from the the base on this one, so we're not actually doing that skip of that step. But what we have here is then, yeah, the base weapon of the FAMAS, 2.3 being 130% weapon damage, 2.54 being from the 154% crit damage that we have, 1.2 from Obliterate, 1.9 from Striker at full stacks, 121 from the damage to health, and a 1.1 from damage to targets out of cover. Kind of covering all of our bases. So yeah, we have this 802,618. Let's actually double check in the game that we're hitting that number. And of course, I've already done so, but just to show it as well. If we are at full stacks and have accounted for all of our modifiers and such, multipliers and such, we hit this, yeah, 802. Let's actually get it on the side there at full stacks. There we go. 802,617. We go back to the spreadsheet. And of course, this is just a quick and dirty calculation without using, for instance, yeah, a multi-calc or something like that. But yeah, we can just take that base damage, just account for all of our multipliers, and we reach this 802 back there. And what we can do now is actually take our final damage that we have here. If we take is this number divided by our base. Now, of course, this you could also just do by shooting at the range like we are doing there. Taking the damage number from in the game, you would need to know the base of the weapon, but that, of course, you can get from several sources. This 17.7 that we're getting back here, that is the multiplier of the build. So it took whatever the number was here at the base, and basically all of these together add up to a 17.7. And that's actually a very handy thing to know about, because, for instance, what we can use this for is to compare builds just easily against each other. Now, here, of course, we're not accounting for crit variances and stuff. We would need to do it with average shot or such, but you could actually, of course, do that as well and get an average shot multiplier, because you could get, this is just the crit, of course. You could get the non-crit, basically 60% of, if it is at 60% damage, 60% of the multiplier of the crit version, 40% of the non-crit version. Add those together, you would get the same number, kind of. And yeah, this number is actually quite valuable. And from now on as well, I will actually, in build showcases and such, add in the multiplier and show that as well, just as a number to compare against. The thing would be, though, that this number output would be the same percentage difference. And that's generally what I am concerned about anyway with build showcases and such. When we do the calculations, we take it to a percentage difference between the builds. The percentage difference between, for instance, if we take this from doing it in this way versus a chest striker, would be the same percentage difference as in DPS. So there is definitely value, though, to knowing it, doing in this way, and you'll likely see more and more of this way of doing things as well. And of course, especially the handy thing of this is we don't even need to have the whole calculation here, or even a calculation. What we especially need is the base damage of the weapon. And what we do then is here, for instance, I've taken a little bit of a different build, still striker, as you can see the stacks there. I'm gonna stack up here, and yeah, from that you should guess that it is a chest striker because it needed a bunch more stacks before it was at full stacks. I'm gonna try to land on this 985. Yeah, so 985,664 is our maximum hit on the crit. If we take this back to here, and I just input this number here, basically just 985,664, just taking it from the game. If we copy this multiplier over, so now we can see that we don't need to know all the steps in between. And that's not something that is per se needed. We just need the start step and the end step. And from that, we can get a multiplier. But very importantly, you need to watch out actually with how you use these multiplier numbers, because, for instance, here, going from this to this is just a crit number. If a weapon is adding more from base, that's going to, of course, make a difference there. But if we're just comparing two strikers, and then, for instance, here, this was, of course, just a chest striker with the same crit chance and crit damage, specifically, just to keep it fair, because if one has 60, one has 51, that's, of course, that's not represented in here because we're just looking at the hit. Plus, here, in neither of these is included the rate of fire from from Striker. We can just add that in. That would just be another 1.15 multiplier. It wouldn't be this hit, but it would be post this hit. Basically, it would be just in the RPM side of things. You would need to include it if you're, for instance, comparing Striker versus, let's say, Heartbreaker or something, or, you know, Umbra or something like that. So it is important. And then also, we're just doing the crit here, but yeah, as we talked about, we can do the crit and the non-crit. We can take both multipliers and kind of average multiplier them together in the same way that we do average shot. And that would get us an average multiplier for the body shot, crit, and non-crit. Now, of course, you would also basically need one for the headshot version, especially with a build that maybe has a different amount of headshot. But especially if the headshots are the same, you can just go off the body shots, because if both of them add the same amount into the headshot, there is a little bit of difference because it depends on how much crit damage they have, because those two are additive, of course. There's a lot of caveats to this, but as a quick and dirty calculation, yeah, we can just take, for instance, here that the chest striker has, yeah, basically a higher multiplier, which we already knew, of course. What we can do as well is just take a percentage of this. So if we take is this number, or well, actually, it's this number divided by this number, how much do we gain? That 22.8%. And actually, yeah, from knowing the DPS calculations, it is usually around the 20% increase going from the chest striker, going from obliterate striker to chest striker. But just here, we don't have the subsequent steps. We can't play around with the stats or anything. But as a quick and dirty number, this is much more useful than going, I'm hitting for 1,000,000 with this build. Because first of all, that doesn't tell us anything about the weapon or anything like that. At least if you take it as a multiplier and you say, you know, this build has a, for instance, yeah, 17.7 multiplier across it, going from the base to the crit hit, we can tell a lot more from that than we could from other sources. And yeah, knowing the multiplier is a very useful thing. And to conclude this video on media maths, I hope you enjoyed coming along with some of this nerdy quirks and shortcuts and such of the systems. And of course, as well, I did redo this video as, or parts of it as the parts that went up. Yeah, I first was kind of convinced that crit damage should actually be done with the multiplier being treated as the multiplier. Turns out that that isn't the case. The chance and the crit damage should go together first before the 1+ comes in. And because of that, yeah, I recorded parts of this, as you may have noticed. Some parts were older than others and maybe sounded a little bit different as well with some of the parts I noticed. But that's beside the point, as I did catch it, at least for myself, I feel fast enough. And yeah, we didn't put out any bad misinformation for too long. And with this as well, I hope I've shown that, yeah, crit chance, crit damage should be done in this way. And that's really the only way we can make it line up. Turning this video a little bit into a for no particular reason as well, as I've definitely seen the argument of that side. And well, I was even on that side for a little bit. But yeah, thank you for joining me on this video. For future videos, we're going to go into actually the several guides are kind of coming to conclusion, so we're likely going to jump to actually putting out a few in-depth guide videos. And of course, the Eclipse masterclass is going to be coming along, as well as I want to do a redo basically of one of my oldest videos, actually basically my oldest video on the channel, which is the Fire Eclipse masterclass. It is a little bit old, it is a little bit out of date. Stuff has changed game-wise as well, so it's from the time when Golan was the pick and Electric did not exist yet, so that's how old it is. So yeah, we'll likely do a redo on that, and actually in the coming time I'll be pretty free as work is dialing down a little bit on the summer end, as it always does for me. And that means that, yeah, I'll be able to spend quite a bit of time making some videos, and I'm intending to do so, especially the skill guide video will likely become a ton of videos in quick succession. So yeah, I hope you joined me for those. If you did enjoy this video, please do any and all of the algorithm things down below. It does help out, so I'll do that little bit of shilling here. I hope to catch you all in the future. And as always, have a good night.